Okay, early morning hustle. Well, at least it's going to be early morning for me at least. And so for today, at least this video, we're going to emphasize using, or at least learning the various statistical techniques within R. I know we're in Stat 331, and most of the stuff that we have been learning has been just, I would say, data science related. Whereas in this particular video, we're going to spend time on utilizing various statistical techniques. And we are in a flux because, truthfully speaking, I try my best to only teach you one of the methods with regards to this tidyverse philosophy. But in this video, because we're a little bit in a flux in that both the old version as well as the tidyverse version, they're both being used. So for each and every statistical technique, I'm going to provide you with two ways of actually implementing the technique. So with that being the case, let's go ahead and begin. So we have this penguin data frame from 2006. It was collected by this lady. What is her name? I think it was Kristen Gorman. And this data set was collecting data regarding penguins. They collected various variables such as species, bill, length meter, flipper, length meter, their sex, body mass, and we don't have the year of observation, I don't think. But long story short, this is a now famous data set within R, or at least you have to download it to get access to it or install it. You're going to eventually install it. And what's funny is that every single time I see this, I think of that one TV show on Netflix, Chin Strap, Gen 2. Okay, but that's fine. So if you know the show, I'm not going to say the show's name, but if you know the show, put it in the comments below. So when it comes here to in terms of data ethics, she's allowing us to use this for public use, so that's why we're able to use it. We're going to talk about various statistical techniques, but I'm going to talk about primarily what we did in 252, or what you probably have seen, or you would have seen if you took 252, the entire class, and some elements of 251. And so we're going to look at 10 different techniques, but you have to install some packages first. So this Palmer Penguin is used for the actual data frames. Tidy models will be more so next video. And then we also need this function called infer. That's what we're going to use primarily for this video. We traditionally would use, if this is a pure statistical, learning course, we'll talk about different packages such as this to do multiple simulations. But we're not going to do that here. That's fine. So this is a perfect place for you to install the packages. You need Palmer. We're going to need, you should already have TidyR. Tidy models you should install, as well as infer. You should know how to install packages by now. So it's fine. And again, I'd like to emphasize that we're going to primarily work on syntax. We're going to primarily work on the different syntax in terms of implementing the statistical techniques in R. And so in terms of code, I'll give you a lot here. I'll give you, because I have this theory in terms of teaching my 252 or 252 course is SSVA, summary statistics, visualization, then analysis. So I do the summary statistics and visualization for you all. And when you see the code, it should be a surprise. But then in terms of analysis, it's going to be a little bit new. And again, so I'll work on this later. This is going to be the next video. All right. So in terms of implementing these statistical techniques, this is the first one population mean. And here I'm going to go through the statistical process in that we have a statistical question. Colloquially speaking, is the average body mass of penguins in a data frame equal to 4,700? Whereas in terms of using statistical terms, saying if the population mean of body mass, the population mean, you have to specify the parameter of interest here. And colloquial means just common language. And whereas statistical, we're going to actually utilize statistical terms like population mean. All right. So here, the primary use of one population mean test is to determine if a population mean of a single value is significantly different from the specified value. or is the specified value plausible based on the data? And so we're going to be looking at body mass. And so let's look at the summary statistics here. There should be no surprise that we can do this. The actual sample mean is 4,201. Standard deviation is 801. Sample size is 344. Okay. So we're going to use the Penguins data frame. I don't know if you noticed that there. Penguins data frame. Then we're going to visualize this. I made this quite nifty. I made this really quite cool, I think. So I provided some text in terms of what our hypothesized values would be, as well as what our actual sample mean would be. So in this visualization, you have the hypothesized mean in red, and then they have the sample mean in blue, as well as with the vertical lines. I'll say this is slightly skewed right, but that's fine. And so this is a histogram that allows us to see the data. All right, and then I also provide the ability for us to see the null and alternative hypotheses. Okay, these is how you can provide LaTeX code within R, within double $sign. Okay, and so in terms of doing this, this is one of the this is quite not a little clunky, but we have to utilize the $sign notation. I did my best not to use that in any. I try my best to not use that in any other scenario. But it requires it for these first two tests. So here is the code. So the function for us to run this actual hypothesis test is to utilize t.test. So this is the old method. Oh wow, it did it for me. Oh wow. Let me turn that off. Okay, so the $sign method allows us to extract just that vector, like kind of using select, more specifically using another function called pull, because it gives it to us as a vector, which is fine and dandy. But this is not but that's just the way you do it. Okay, that's just the way you do it in terms of utilizing the t.test method. As you can see, I'm specifying the actual hypothesized value. I could do other things to this. I can like specify the alternative. That's a one-tailed test, but that's not the point of this video. So we're not going to do that. So it gives me my test statistic, my degrees of freedom, my p-value. If I wanted to do another alternative hypothesis, I could do so as well. This also gives me the confidence interval for the actual parameter of interest. As you can see, 47 is not within that interval, so it's no surprise that our p-value is extremely small. So this is the old version of doing it. And so this way is nice, but the issue is this is the object of this. I don't know what the object is. Let's say we'll call this tempt. And then if I were just to say class of tempt, not good language, not good H-test. That's fine, but sometimes you would want to extract the actual data from the analysis in an easier way. You could still extract it, but it's not as intuitive. But here, utilizing the infer package, we can legitimately take penguins. If I can spell it correctly. Penguins. I'm going to pipe this. And the actual function, if you saw earlier, is just t-test. And this is going to potentially cause an error, and I want to show us what it is. So I'm going to provide it a formula, and I'm going to say body. Since I'm only doing it with one variable, I'm going to do tilde null. That tilde is going to come up a lot throughout this next two videos. So it's just showing a relationship between no variable and the variable that we're interested in. And I will specify that I'm looking at mu is equal to 4,700. Okay. So when I run this, oh, I got what I want. Okay, so negative 11 is my test statistic, negative 11.48, negative 11.49, 341. So now this is a tibble. We haven't really spent more. That's like a. We'll talk about that later. But this is still a data frame that can extract the various variables within each column. So it gives me all the same information. Okay, and this is using infer, t_test. Okay, so that is one technique. 4 more to go. One population proportions. Okay, so this one here, I decided not to use sex. I went ahead and just I created a new variable. So what I'm asking is the proportion of penguins with a bill length greater than 40 equal to 0.65? So I'm looking at a quantitative variable, and I am turning it into a binary variable. So if it's greater than 40 millimeters, I'm going to say that it's true. If it's less than 40 meters, less or equal to 40 meters, I'm going to specify that it is a false. And so notice that I didn't say population here, whereas here I say population proportion, because this is a statistical technique. So here in terms of, so when it comes to the statistical method, we're dealing with one population proportion, and what we're trying to determine is if this population proportion, right, this population proportion is actually equal to 0.65, equal to a specified value, okay? And so I'm actually going to filter out the NAs within this, and then utilize this if-else function within a mutate to now get my variable. And I'm only going to focus on that one variable, so I'm just going to select it. And so since this is statistical analysis 2, I say it's stat2 df. So run this, and if I want to see it, gotta make sure I practice what I preach, what I remember. And so you have all the columns, all the rows, according to that transformation, okay? I can now view this as a table, okay? So that's the frequency of less than or equal to 40, and then greater than equal to 40. Greater than 40. And then I made this kind of fancy. And so this is going to show us the frequency using geom text on each bar. Okay? And here we go. Here's the bar plot. So the summary statistics, the visualizations, and then finally the analysis. So the analysis, the null hypothesis is that P is equal to 0.65, and then the alternative is that P is not equal to 0.65 once it show itself. Okay, you know it worked. Okay, good, it worked. All right. For this one, let me get the code out. For this one, it's going to look very similar in terms of the $sign. You have to supply it with two pieces of information. You're going to use prop.test, okay? And I could have use the table function of stat2 $sign bill, and then I just tell it the number of rows I have, so the sample size, n row of stat2. And then I'm going to tell it the hypothesized value, p is equal to 0.65. Okay, so then this should give me a bunch of information. Okay, it says chi-squared. You can ignore that. This is the test statistic, 1 degrees of freedom, because we only have one. It's a categorical binary variable. It's the p-value. That means we should reject the null hypothesis. This is interval of plausible values. So 0.65 is on the cusp. Okay, which is fine. Now, so that's the way we would do it using the old technique, or at least the old way of doing it. But the new way of using infer, drum roll please, is to do stat2df. Again, we could have been using the original data frame as long as we saved it, but we saved it in stat2df, so that's fine because we created a new variable. And the function within infer is called prop test, and we're going to say the response is going to be that variable that we're interested in. So this is a little interesting. So bill length greater than 40, and then success is going to be equal to what variable that are we interested in? What level are we interested in? And we're interested in greater than 40. So we're specifying the level that hopefully you all notice that we're specifying that the level. My alarm's about to go off. Oh no. That we defined up here. Okay, but it's not part of the hypothesis test. So once we do that, you see my alarm. Okay, turn it off. Okay, good. So now that we have that, we have to do one more thing. We have to specify the null. That's going to be p is equal to 0.65. and then we run this. Again, it gives it to us as a table, but it's a data frame nonetheless. 4.73, 4.73. Degrees of freedom is 1. The p-value is equal to 0.029. So if you see in how they keep mentioning chi, this is that stat class for me to show you how the chi-square test, chi-square test, one of the tests, how goodness of fit is related to two or one population proportions. It's not the time for me to mention that here, but you can see you're getting the equivalent results of which we got here, so we're good to go here. So 2 methods down. Oh, okay. Yeah, 2 methods down, 3 more to go. And you can see this is a little clunky, right? You could specify this differently, but still, it's a little clunky. This one, it's almost formulaic compared to the t-test mechanism that we did for the one population mean. Okay? So let's go to 2 independent population means. So here we have 2 variables. So do Adelaide and Chintrap penguins have different mean body masses? Okay. And then in terms of using statistical terminology, you say, is there a significant difference in population mean body mass between Adelaide and Chintrap penguins? So here the primary purpose of 2 independent population means is to see if 2 means are the same or not. Okay. And so here I'm doing the n little operator so I can focus on these 2 particular species. Because if I don't do that, let me show you. So if I do table penguin $ species, you see there's 3 species, Gen2 as well. So I want to ignore Gen2, so that's why I'm gonna just run this. And then when I do a group by and then summarize means and deviation sample size, I get all the right summary statistics. Okay, all right summary statistics. So the primary purpose is to see how far this difference between means are, which is from 0. How far they are from 0. But notice that the standard deviations are quite equal or quite close, right? In my Stat 252 class, I traditionally say that if the ratio is less than or equal to 2, we can assume that the variances are equal. And we're going to use that fact to make a modification to our statistical technique. All right. So then here, this is again a nice, I use ChatGPT to spruce up this visualization, right? So not only do I have a box plot, but I also provided the mean on the box plot, right? So we have the mean here as well. Okay, look quite similar. All right, that's cool. And then in terms of my non-alternative, we could have wrote this in 2 different ways. Come on, show yourself, please. Okay, the alternative is that they're not equal. Then the null is that they are equal. And then here's the old code. Okay, I know this for pure fact. T.test is going to be, not I've got the variables. Species is going to be on the left. And then what's going to be on the right? No, left is going to, body mass. Body mass is going to be first. The response variable, body mass, I think that's what it is, G, tilde, species, I think I'm spelling that right, and then you're going to say tab, or you're going to say D, data is equal to, I'm just going to say penguin. I didn't do anything special with this. Oh, did I? I think I did, never mind. I didn't need to do this. Penguin, I need to do stat 3 df, okay. Because I only focus on those 2 species. So here, this is a Welch's t-test. This is fine. But remember when I talked about the standard deviations that they're approximately equal? Right here? We shouldn't use the Welch's t-test. We should use the pool t-test. And so the argument for that is to say var dot equal is equal to true. To delineate or to utilize the pool t-test. Okay? The values are a little bit different. That's fine. The test statistics is calculated in a different way. Here's the p-value. We should fail to reject our null hypothesis. Okay. And then lastly, in terms of the infer method, we're going to do stat 3 and then t underscore test. I can't believe I look that up. T underscore test. And then what we're going to use is formula again. from the first technique, formula, is equal to body mass G tilde, we're going to say species. Okay, and this would work, but it's going to give us our same result. This is good. So good problem to have. So it says, please supply a response variable that is not null. So if you go here to stat3 df, you see some NAs. We have to specify, for this particular technique, we have to specify to drop it. Drop those NAs. So I'm going to say drop underscore NA, and that's about it. Oh, that's not right. Drop NA, I need to specify the actual variable. Body mass. That nice. So formula is equal to body mass tilde. Give me 1 second. Let me try. Who caught the error? Ha! Well, I didn't test out to see if this is really the error, but let's see what happens. There we go. There we go. And let me even comment this out. Let's see if it still runs. There we go. I don't even have to use that. Yikes, so embarrassing. Spelling is essential. Well, this is the same test statistic that I got before. And so therefore, I need to do var dot equal is equal to true. Here, just so we can get that same statistic, and it works, and it provides the pooled t-test. Okay, so that's good. So I really thought these videos would be a lot shorter. I really like talking, so I'm gonna make the next video right after this. But y'all need a break, take a breather, go for a walk. We'll do 2 more of the chi-square, the other 2 videos, and go from there. All right, thank you.